Okay, good morning, everyone. So my name's Matt Lewis. I'm Chief Architect at the Drive and Vehicle Licensing Agency. And I'm delighted to be here to give a little introduction into our journey into serverless. So before I dive into our sort of use cases, I want to give a bit of a background in terms of who we are and give a bit of context in terms of why we're starting to look at serverless. So we're fortunate in terms of most people are aware of who the DVLA are because they have a driving license or they're registered keeper of a vehicle, which means that they have to tax it. We have a number of primary functions that we carry out, and although we're although we're relatively small in size, if you compare us to other departments, so the likes of DWP, HMRC, in terms of our breadth and the volumes that we process are actually quite big. So this slide just gives an idea of some of the numbers that we processed, and this was taken, I took this from sort of the end of last month. So when you consider, I think in 2015, it's estimated there was around 27 million households in the UK. And we maintain a register of over 47 million driver records, over 39 million active vehicle records. And what that means is that we interact with virtually every single household in the UK at some point. So in terms of the breadth, the coverage that we have, it's pretty big. We also collect just under £6 billion worth in vehicle tax. That sort of changes on an annual basis. And that puts us one of the top 25 merchants in the UK alongside the likes of M&S, John Lewis, Amazon. And because of the number of card payments that we take, we're classed as a tier 1 merchant there. In the last, it's just over 2 years ago, we introduced direct debit as a way of paying for vehicle tax. And I think in the 2 years since then, we now have over 16.5 million direct debit payments that have been set up. The other thing I wanted to touch on was around efficiency savings. And so we're committed as part of the comprehensive spending review to take a significant amount of cost out of the business. And one of the ways that we're looking to achieve that is by moving away from our on-premise monolithic legacy proprietary systems and start disaggregating them and start moving them, so re-engineering, transforming, modernizing them and moving them to public cloud. So why is that important in terms of serverless? So hopefully there'll be a number of people here that are familiar with the work of Simon Wardley in terms of his evolution curve and mapping techniques. So what Simon's sort of shown is that any sort of component, when it comes under competition in terms of supply and demand, it evolves and it goes through that well-known curve. So you start off with something that's first of a kind, it's a source of wonder, and it moves on, so it's a custom build, it becomes a product, and eventually, under pressure, becomes a commodity and then a utility. And so what we want to do is we want to make sure that because we're trying to deliver at pace, that we focus our time and effort in terms of focusing on those things that are of value to us or unique to us and not on things that are commodity or utility that we can consume as a service. So when we start looking at serverless, what that means is our engineers don't need to worry about configuring instances. They don't need to worry about provisioning capacity or scaling or things like dynamic service locator. They can literally focus just on writing the code and know that the platform is being provided underneath that underpins that. And we also know that it's sort of the direction that the industry has taken. You know, Matt mentioned things like AWS Lambda, but we see things like IBM OpenWhisk, Azure Functions, Google Cloud Functions. So there really is a drive towards serverless. And then in terms of the areas that we're looking at, we've got sort of 4 use cases that we've been working on at the moment. So they're around API management, health checks, prototyping, and customer interaction. So I'll quickly run through each of these. So in terms of API management, we're just going into private beta this month in terms of our first candidate around a managed API, and that's the Vehicle Enquiry API. Now, we actually only made the decision so either the end of October or the beginning of November that we were going to utilize API Gateway, a little bit of Lambda and Cognito. And there were some important characteristics about that led to that decision. So the first is around scalability. So the chart in the bottom right shows the number of vehicle inquiry requests that we process as part of it. It's an online set of web screens that were originally provided just to dealers to allow them to when they get a used car onto the forecourt, they don't need to worry trying to look in a logbook to understand what the details are. They can, or phone up a contact center. They can literally just enter the registration details online. And that used to trundle along. We used to process somewhere between 500,000 and 1 million requests each month. And then we abolished the tax disc. And I think what we didn't recognize was that there were a number of people that saw the token in the dashboard as a sort of an identifier in terms of the roadworthiness of a vehicle. So as soon as the tax disc was abolished, we started seeing the demand for that data increase, and we started seeing people building apps, screen scraping, and a whole sort of ecosystem develop above that. So it went from processing less than 1 million to processing, like last May, it was more than 51 million. And then when we spoke to organizations, because as a general principle, we're going towards API first, so we want to expose data and services through APIs and allow a whole ecosystem to deliver things rather than ensuring that we have to deliver everything for ourselves. We spoke to 6 organizations, and one of them has already requested they want to use over 1 billion requests. So we're now going, in terms of the scale that we have to handle, we go from what originally was tens of thousands, hundreds of thousands, 1 million or so, tens of millions, and now we're having to develop an API platform that can scale to handle billions of requests. And that's where the API gateway came in, because it's a fully managed service. So we don't have to worry about capacity and provisioning. By default, soft limits, it can handle 1,000 requests per second. It can handle bursts of up to 2,000 requests per second, and those are the soft limits. So again, we didn't have to worry about configuring VPCs, configuring subnets, CIDR blocks, IP ranges, and so on. We could just focus on trying to deliver the functionality. Second one is around metered. So, I touched on the fact that we're trying to move away from our big monolithic legacy systems. Now, that's something that doesn't happen overnight. So what was essential for us is that we could provide controlled access to the back end, so we can sort of protect our existing back end services while we're in the process of migrating them. So API Gateway introduced something called usage plans, but that didn't come out until August last year. So before then, it wasn't even a viable option for us. We'd had to start building our own sort of token bucket algorithm, investing a lot of time and effort in that. So what usage plans allow you to do is they allow you to specify rate limits, specify quotas, and effectively control access. So restrict access to who can actually access the API. And it also offers some additional nice features that have started being introduced. So we can apply things like a rate limit. So the rate limit tells you in terms of how many requests per second, but you can also specify then a burst limit. And the burst limit is effectively the maximum capacity of the token bucket for that particular operation. But you can specify that not just for an individual user, so effectively for an API key associated with a usage plan, but you can specify it at an account level, you can specify it at a stage level, you can specify it at a method level. So what that means is we can open up an operation, an API, so get vehicle details, and even if we were to say things like anyone can sign up and they can make 10 requests per second, but we can limit the maximum amount of throughput that we can handle by specifying a limit at that sort of operation level, as opposed to just allowing a flood of requests to come through and endanger the back end. And finally, security. So, we maintain a register of driving vehicles, and we act as the data controller. So that means, in terms of the Data Protection Act, that there are legal responsibilities placed on us, and we take that responsibility seriously. And that means that security has to be a first-class citizen. It needs to be baked in up front, and it's not something that can be retrofitted at the end. And API Gateway comes with a number of various different access mechanisms that you can do to control access. So for us, it's a public API. There are certain nice features in terms of it enforces things like an HTTPS endpoint, so you always know that the data is going to be encrypted in transit. And we're using Cognito, so effectively setting up a user pool in Cognito. And in doing that, so we use Cognito in terms of to sign in users. We can also put in, we can enforce through Cognito that when a user signs in, we can verify the email address and the mobile phone number by sending a notification. There are a number of additional security controls that we can put in place as well. So it supports things like multi-factor authentication. You can sign API requests. You can pass in tokens, and these tokens will expire after an hour. So when someone signs in, they'll get effectively an access token, an ID token, and a refresh token. So all these things that can be put in place depending upon the necessary controls that are required for an API. Our second use case is around health checks and housekeeping. So there's a lot of that's very similar. People are familiar with the concept of chaos engineering and things like SecurityMonkey. So we want to try and enforce some standards. So we pick on one, which is around tagging. So we use tagging quite extensively, and that's for cost allocation. So we then have a choice in terms of we can specify standards that people need to adopt, and you can either sort of enforce peer-to-peer code reviews looking to check, but what we've done is automate it. So there's a Lambda function that gets triggered, and we start seeing more of these things come out in config rules now. So we specify in terms of when if an EC2 instance spins up, we'll have a Lambda function that gets triggered. It will check to see, does it have a tag? Is it a tag that's valid? And if it doesn't, it just shuts it down. So we can start enforcing some of those standards and governance by making sure that nothing runs that shouldn't be running. It allows us to sort of shut down long-running processes. And from an API perspective, we use it to create custom reports. So what we do there is we use something called CloudWatch Scheduler. So on a sort of every 10 minutes, every hour, every week, we trigger a Lambda function that runs, and it starts interrogating the CloudWatch logs and generates these custom reports, which it then pushes into an S3 bucket and allows us to analyze at a later date. Our next use case is around sort of prototyping. So we use a tech radar that effectively says that we need to keep looking in terms of how technology is evolving, what's coming up. And we have serverless down as assess. So we see that there is significant appeal to it for us, but we want to understand what the impacts are. So we know, for example, I touched on tagging and the fact that we use tagging extensively to do cost allocation, but at the moment, API Gateway Lambda doesn't support tagging. So we need to understand some of what the limitations are. We need to understand, not just from an API perspective that makes sense for us, but as we start looking at, would it make sense to adopt serverless for our transactional services? How are we going to group our functions? How are we going to share common code? How are we going to define our dependencies? What are we going to do around configuration management, exception handling? So we started running some prototypes, and as part of that as well, we're able to analyze what the difference in cost model is between running EC2 instances versus running serverless. And for us, our target architecture, we're very much moving towards an event-driven model, which is why serverless really does suit us. And finally, customer interaction. So on the original slide that I put up around DVLA in numbers, we handle around 500 million customer interactions each year. So we are very much a customer services organization. We focus on user needs. We put the customer at the heart of the journey. So one of the things that we want to do is start identifying how might customers want to interact with us going forward. We try lots of things. We have things like a digital driving license that's being evaluated at the moment. But one of the other aspects is, that personally I'm quite excited about, is voice computing. So we've already seen announcements over the last few weeks in terms of manufacturers who start building support for the Alexa voice service into their hardware or into some of their products. So we've started trying to identify ways in which customers may want to interact through voice commands with the DVLA. And that's where things like the Amazon Echo and the Dot, they start coming into play. And it actually has a benefit for us because one of the ways that you build an Alexa skill out is effectively writing a Lambda function. So it has a side benefit of, one, our developers find it interesting and exciting, but it also allows them to build up skills in these types of new technologies. And that's what we've seen. When I touch back on things like the API management, we started evaluating, we chose to use the API Gateway product with a little bit of Lambda and Cognito back in November. And because we didn't have to worry about provisioning servers and capacity, we didn't have to worry about how we're going to configure all of these VPCs and subnets and manage the servers. We've gone from deciding on a product set that we want to use to handle billions of requests to actually rolling it out in a matter of weeks. So our development lifecycle, which historically has probably been measured in sort of, I'd like to say months, possibly years at times, we're coming down now to days and weeks because it's something that frees the developers up to focus on what they know. They focus on adding value. And that's the most exciting thing for me in terms of they don't need to learn unique skills. They're comfortable around things like AWS CLI around the console, comfortable with the products and services. So it's very developer friendly. And so the big thing for us is the fact that not only are we having a play around with serverless in a number of different areas, but where we are adopting it, we really are starting to deliver at pace. And that's all I wanted to touch on. So thank you very much for your time.
Matt, thanks very much for that. That was really interesting. I wonder if you could say a few words about sort of source control management issues, because I assume we're talking in reality about what are fairly complex applications, so multiple serverless functions and handling the interactions between those things. And I just wonder what your experiences are in terms of the way developers work.
So it's why we're starting looking at the prototyping. So for things like API Gateway, we're writing fairly, it's fairly simple functions that we're having to write because they only have to do one thing and do one thing well. So they follow our, typical. So we use things like Bitbucket and promote things onto GitHub that are allowed to go in the public domain. And then we typically use Ansible in terms of building things out. They deploy it as a zip file into S3, and then that's how they then end up getting deployed into Lambda. So it still follows a standard process. We're looking, we've been looking at other things. One of the things I touched on was looking at things like serverless application model, and where we look at things like that, and we start looking at products like Terraform and CloudFormation. So there is a team that look at that, and that's one of those things that we know that, it's a challenge of moving away from big monolithic applications where effectively they all exist in a single code base. They're deployed into a single process. We're moving into a distributed world. So when you start having to handle multiple functions, it's one of those challenges, which is why we start prototyping. Why we started prototyping things so we can learn from that. But again, it's using our standard toolings at the moment. So things like Ansible, Git.
Okay, thanks.
Any other questions? Okay, yes.
Thank you. From a development perspective, one pain that we've been having with Lambda is how to integrate with the existing, software engineering best practices in terms of testing and so on. Did you guys have that pain as well?
Well, that's, again, it's a similar, we have this one that we didn't want to do wide-scale adoption. We have the one that, there's differences in terms of not being able to develop locally. We do have the one in terms of, like I say, there are certain things that you have stages which equate to sort of environments, and we actually separate out. So we have different accounts for development than we do for things like production. And then in an API world, we have a development AWS account, and inside that we have multiple stages. So there's like a dev and a UA. But yeah, it is different in terms of how we're able to sort of trigger those events. So effectively, we have a running environment that we need to do to run some of those automated tests.